Hello everybody and welcome back to G-Bear's Off-Grid Ways, a homestead in the desert. And yep, in the shop today, 30-mile-an-hour winds out there. Just ridiculous. I got a side job, can't do it in the wind, but I can get other things done, so that's what I'm working on. So, I had to clarify a few things on electrical, so let's get into electrical today. Alright, sub panel. Main panel, I don't care, either one. They're pretty much the same. Now, inside the panel, everything's taken out of it. No wires, no breakers, nothing inside of it, all ready to show you what's going on. Okay, these are where the breakers connect. Okay, a breaker is like this. It has a hook on this bottom side, and then on this side it has two little plates that are spring loaded that clamp together. So when you hook that into the unit like that and then press down, it snaps into place and makes contact with the stab right there. Okay, so there's every other one of these. This one, then skip that one, go to this one. This one, skip that one, go to this one. So every other one is on a separate bus bar. So this bus bar, I can see connects. Oh, that's my ground lug. That's what I was looking for a little while ago. Anyway, this bus bar and this bus bar have tall pieces on them. So they connect to one of these two lugs here. Okay, this is line 1, line 2, or line 1, line 2. It doesn't matter how you want to set it up, but these are your two hots. One of these goes to the first and the third. The other one goes through the second and the fourth. Okay? Now, when you have two lines coming in like that, each one is 120 volts. So you're going to have two of them coming in. That'll be 240 volts if you go across two lugs. To do that, you need a 240 volt breaker like this. Now this is two breakers put together, 220 volt breakers put together. But it's the same thing. It's got hooks on this side, and then you push it down and snap it into place on that side, just like that. Okay, that's all there is to it. All right. So, what are some of the other components inside of here? Well, you got this bus bar here, and then you got another one that's kind of like it down here. What's the difference? Well, this one is up here because it's isolated using the Bakelite isolation from the panel box. That's so your panel box does not get charged with electricity, so you don't get shocked when you touch the electrical panel box. Okay, so that would be your neutral. So down here you have two lugs to connect your main neutral coming in. So you'll have neutral, line 1, line 2. Neutral, line 1, line 2. Okay? So that gives you your power inlet. Now you've got to have a ground, or what they call bond or earth. Okay? Earth, ground, easy to remember, right? So anyway, they have this big rod that comes with it right here that you fasten with a screw to the box. That's so that you can bond your box or your ground bar to a ground rod that you drive outside 6 feet deep into the ground. Okay? Now the ground, notice, is just connected straight to the metal box. Now, if you have a box that doesn't have a ground in it, a ground bus bar, you can actually buy just the ground bus bar. This is a neutral bar because it's got the Bakelite insulator on it. So if you fasten this in a box, it's no good as a ground because it's not grounded to the box. But if you did put one like this in and you wanted it to be a ground bar, just because you had nothing else at the time, you could go from one of these lugs right here down to this thing right here, and that would ground your buzz bar. Okay, so you can put this in like this, loosen the screw, bend this rod so that it fits into here or into any one of the screw holes, and that would give you a grounded ground bar. They don't like you doing that because an electrician looks in a box, he sees an insulated bus bar like that. To him, that's a neutral bar. If it was uninsulated like that, he knows that's the ground bar. Okay, so you don't want to mess with the way things are set up. So unless it's an emergency, don't go with this and a bond wire from the bus bar to the box. All right. Now the other thing you can do is on these, let me see if I can set that down. There's two little screws right there. If you take those two screws out, this bus bar will come off of the Bakelite insulator. Now you can take this bus bar and fasten it directly to your box like this one is. Okay, and if you don't have machine screws that came with the box that fit and are in the right position, what you can do is you can take out one or number 2 ground wire lug here, and then the second one in from this side, and you can use a self-drilling, self-tapping screw like this to go through that unit and then just screw it right into the panel. All right, that'll drill through metal and make threads to anchor it in. So that's one way of doing it. All right, so if you're going to hook a ground wire to this, and then put all your other ground wires in this, because they'll be bonded, because this is connected to the box and this is connected to the box, so they're bonded together. So if you just come in with your ground wire from your ground rod and connect it on here, you'll need a lug like this to slide over the end, and then you would slide your wire in alongside of that, and then tighten the screw on the unit until they're both very tight. Okay, and that gives you your ground. All right, so remember that you're going to have a separate neutral bar is insulated, ground bar is not insulated, it's connected to the box itself. All right, and one of the reasons for this is, okay, both your line in and your line, both of your line ins, line 1, line 2, are carrying current into the box. Now remember, this is AC, and AC stands for alternating current. So you have to have something bringing the current back again. That's what the neutral does. So like right here is your wires in your house. Your black is your hot, your ground is your ground, and your white is your neutral. So the power comes in through the black and goes back to the panel through the white. So both the black and the white are current carrying wires, so you can't hook the ground to a current carrying wire, otherwise you have a ground fault. All right, so if you have a GFI in the circuit, GFCI, ground fault circuit interrupter. Some guys call them GFCs for short, but if you have one of those in a circuit and you don't have your neutral and your ground bar separated, it's going to keep tripping your GFI because your GFI doesn't have a ground. Okay? So that's important. All right, so we got that cleared up. Now, let's move on out of the panel and go to a GFCI. Okay, here's two different types here. There's one and there's the other. All right, and it's not just different because of the colors of them, but this one also has a little indicator light on there that tells you when it's powered on or when it's tripped. Okay, so if the light's on, it's good. If it's lights off, it's tripped. This one doesn't have that. So this one, the reset button would pop out if it's tripped, and then when you press the test button, the thing would pop. Let's see. Okay, so if the test was out, then it was popped. If the reset is out, then it's popped. So you're going to press the reset until you hear a click, and then the test pops out. All right? And all the test does, all that test button does for information is it puts a short inside of this unit between the ground and the neutral. So when it puts a ground between those, it pops this. That's why you've got to have the separate ground and neutral bar in the panel. All right? All right, now the other thing about these being different, there's the ground screw on this one. Okay, now you see the channel that runs down here? So if your ground screw is loose, I should have loosened it earlier. If your ground screw is loose, you see that square brass plate under it? That will be loose also. So you can shake it and there'll be an opening at the bottom. So you can take a straight ground wire just like this, slide it right down that unit behind that brass thing and tighten it. You don't have to bend the wire. All right. Now, on this type, it doesn't have that little channel for you to go under or the brass plate to go under. So you actually have to wrap the wire around the ground screw and tighten it. And when you wrap wires around any screws, I don't care if it's the ground screw, the hot screw, or the neutral screw, when you wrap it around a screw, you always go clockwise. And the reason for that is when you tighten the screw, it wraps the wire tighter around the screw. If you went counterclockwise, when you tighten the screw, it wants to unwrap your wire. Okay? Little tip there. Okay, so here's a piece of wire. Now, on your wire multiplier or your wire strippers, you got areas on here for stripping wire. Okay? Then you got these holes in the center are for cutting screws. So if the screws on this unit were too long, you can take one of those screws out, you can screw it into the corresponding hole on here for the right size, and then when you squeeze the pliers, it'll cut that screw off, make it shorter, so it doesn't hit something in the box, okay? So that's what those holes are for. So you see, they've also got another hole over here. What's that hole for? Well, simply, when you have to wrap the wire around the outlet, this is so, let me see, how am I going to do this? Let's come over here to the vise, so I have an extra set of hands. Oh, and I'll put my wire in there so it's held. And here we go. So what's that little screw for, that little hole for right there in the side? Well, you put that over the wire until the wire is just sticking through, and then you twist like this, and you have a hook started to go around the screw on your receptacle. Okay, so that's what that little hole is for. All right, then these areas up here are for crimping, and that's for low voltage electricity and some high voltage electricity. Now notice this one has two holes, so you can use this one left-handed or right-handed for making those bends in the wire to go onto the receptacles. All right, so the next thing is, I found it. What's this? This is the MC cable cutter. That's the MC cable right there. So this has a little stopper right there that works on a rocker. So you can put this in and push forward on it like that, and it fits under there. And then when you pull back on it, it holds that tight into place. Now this has got a little bit of a flex in it when you squeeze it. And what that does is it puts that little cutting wheel up against the edge, and then you turn the crank and it'll cut through just deep enough to cut the casing on this without cutting the wires. All right? And then you can take off the casing and expose as much wire as you need. So I wanted to show you that. So that's a handy little tool, especially if you're living off grid and you're going to wire your place with MC cable. You're going to have to do a lot of cutting on the MC cable, so one of these cutters comes in real handy. All right, makes the job go fast and easy. All right, lastly, let's say, like for Tony and Leanne, they're going to put a GFCI inside the wall, and then on the outside of the wall they're going to put a regular electrical outlet, because you don't ever, like I said before, don't ever put two GFCI'S on the same circuit. That's not the way it works. GFCI'S have a line side right there, line, and load side. So line side are the wires that come from the panel. The black comes from the circuit breaker. The white comes from the neutral bar, and the ground comes from the ground bar. All right. So if you're going to put an outlet outside and you want it to be GFCI protected, you put a GFCI inside the wall and then drill through the wall. Use a short piece of wire like this to go through the wall, and then you can hook this up to your GFCI, and then you'll have a white, black, and a ground coming out through the other side of the wall to hook your regular electrical outlet that doesn't have the push buttons. All right, so coming from the panel, you have a ground wire that's going to go to the ground connector. Well, you can see on here, it only has room for one ground wire in there. So what do? Well, what you do is you put one ground wire in there that's about 4 or 5 inches long, like right where my thumb is, cut it off. Okay, and that's called a pigtail. So now you take the ground wire that's coming from your electrical panel and the ground wire that's going to go to your outside outlet, and you wire nut them together with one of these wire nuts. So you put all 3 of them together here in a group, and then twist one of these on as tight as you can twist it. And even if the wires twist a little bit when you're tightening it down, that's okay. You want that to be nice and tight. All right. Now you've got one ground coming from the box going to this outlet, then coming out of this outlet and going to a ground that goes to your next outlet. All right. That's simple. Called pigtailing. All right. You don't have to do that on the line and load because you got the separate screws and the separate holes for those to go in. Remember, on these type, you put the straight end, you don't have to curl it, put it in the hole and tighten the screw. And then that is locked into place. So this would be the line side coming from the box. And then going out of the GFI to going to your outdoor outlet, you do the same thing here. You put it in there, tighten the screw, go to your outside outlet, and connect it out there, whether you have to wrap it around the screw or not. Now, one thing I like to do, if I have to wrap them around the screws, like let's say we were going with this black wire, and I had to wrap it around the screw, like this, I like to use the tips of my strippers to give that a good squeeze to tighten. It's hard to do one-handed, but I give that a good squeeze to get it at least 3/4 of the way around the screw. So I get good contact. All right. You see that now? So now when I tighten the screw, I've got good contact on there. All right. So we've covered everything that I think I wanted to cover today, which is a good thing. And tomorrow, I've got a great project to do. And I'll just give you a little heads up of what it's going to be. I'm sure you might be interested in how this is going to work out. So, let me shut off the light so I don't run my electric bill up. I love saying that. Okay. So my neighbor Ken gave me this big Onan 2-cylinder, thick 6,000 watt RV generator. Well, I took it because I was going to just rig it up so that it would be a spare electric start generator to go on the new guest cabin. I don't need that. The guest cabin is going to be wired to the same electrical circuits as my home cabin and all of these shops, my 2 containers and the garage. Okay, so it's going to have the same power coming off the same system. So I don't need a separate generator, because if I need to run the generator, it's already connected to my other system. So all I have to do is start the generator, and that powers everything that's connected to my panel box. All right, so I don't need it. So I have a neighbor up the road. He has an RV that he just fixed up, that he got for a song and a dance from somebody who had it sitting on their property for a bunch of years and it never ran. And he took his time and went through the books and all of that, and he got the thing running. But it needs a generator. And this is just the right size for it. So I called him up and says, hey, you want it? It's yours. Come and get it. And then if it works for you and you feel like donating something to me for it, then that's fine. If you don't feel like donating for it, just tell me so, and I'll say, okay, no problem. So I've got that white cover on it because of the rains, but that's going to come off. Now, that thing is heavy as hell, and we're going to have to get it up onto a bed of a pickup truck. So how am I going to do that? Well, you see these bars right here? These bars are going to get welded and fabricated into a unit that is going to clamp on to one of the bars from the shipping container down low at the bottom, so it holds it in place, but it'll pivot up and down. Okay, and then right below it there'll be a second pivot with my hydraulic press unit. I've got a big hydraulic press that I can hook up to it whenever I need to, so that I can run the hydraulics and raise that arm up if I have to. Okay, and then on the hooks that are coming out of it, I'll put a third one at the end there, and the hooks will give me different elevations and strength to lift it. Sorry about the wind, people. But what I'll do on those is, it's in the shipping container. Let me head over here. I have a tool called a come along right there. So this has got a cable on it and a hook on each end, so I can hook one of the hooks onto the rod or the bar that's sticking out, then pull the cable out to as far as I want to go, hook it onto a strap going around that generator, and then I can crank it up into place and raise it up. And then if I have to go up a little bit more, I use my hydraulic press and press it up into position. All right, so that's going to be tomorrow's project, and they're still saying 95% chance of rain both Saturday and Sunday for this week. That's fine. I'll take the rain. I'd love to have it. So when I I've already drained my barrels down all around the cabin, so I'm ready to accept that water. I haven't drained all of the water out of my totes up against the container here, but I've got room there for 1,000 gallons anyway, so I should be okay. And the winds are getting stronger. So thanks for joining me, everybody. This is G Bear signing off.